we're going to do our test of symmetry to see what special symmetries the next problem has. So, question B. Now, some of these, you guys, you can probably tell when you look at the equation, which is 3x plus 2, that's our original. If we change the sign on x, you can probably tell that that's going to give you a different equation. Would you agree with me?
Yeah.
Okay, so you don't have to do a ton of work. Your job is to figure out, do I get the same equation or a different equation? That's different, so that one is still a no. All right, now we're going to change the sign on y. Well, again, that's a different equation, isn't it? So that's another no. How about switching y and x? That's a no. If you're at all confused, get y by itself. Because when you get y by itself, it's very obvious that's not the same as the original. And then change the sign on both. Now be careful with this one. Yeah, this is going to be y equals 3x minus 2. So guess what? This is a no all the way down. This one has no special symmetries. Okay? Because when I made these changes, I never ended up with the equation that I started with. Okay? You with me?
Yeah.
All right.
How do you answer it? Do you just go like none?
Yeah, none. No special symmetries. All right, let's try C. All right, so first we're going to, actually, you can use in any order you want. I'm just going in the order I have it written. I'm going to change the sign on x. So this will be y equals negative x squared plus 3. Now notice, I changed the sign on x. So I square it. So it's negative x squared, which that is the same as the original, isn't it?
Yes.
So this one is a yes.
Can there be more than one yes?
Oh, yes. There can be more than one yes.
So we always would have to check every single
Yep.
one.
Check them all. Now again, before you start, stop and think. Sometimes you can just tell. So for example, when I change the sign on y, I can tell that's going to be a no, right? How about switching the variables? If you switch the variables, can't you tell that's a no? Because that has x squared and this has y squared. So that's it. How about changing the sign on both? That's going to be a no. That's going to be a no. Because that's going to become x squared plus 3, but then you're going to have negative x squared minus 3. So that one is also a no. So that one has one special symmetry.
Do you have to name the special symmetry?
What?
Do you have to name the
Yes.
special symmetry? So that-
X-axis, Y-axis, whatever, yeah. All right, you think you got the hang on of that? We're not gonna do all of these, there's some on the back, we'll do a couple more. But before we do, I need to give you a little vocabulary. If a function like this one has Y-axis symmetry, it is called even. So when the question is, you'll see on some page somewhere, yeah, number 8 says, is it even, odd, or neither? To decide if something is even, you do one test, this one right here. If it's a yes, you're even. If it's a no, you're not. test for oddness, origin. This is the test to be odd. And I always remember that because of the O's. Odd origin. So if you get a yes on your origin test, your function is considered odd. If you get a yes on your y-axis test, it is considered even. Okay? And then if you don't get a yes for either one, then it's even. For even, you only do one test. That one. For odd, you only do one test. That one. That's it. To decide if you're even or odd. Okay? Alright, let's pick a couple from this back side. Anybody have a preference? E, F, G, or H? F? Let's do F. X squared plus y squared equals 4. Now, I have indicated that it's not, this is not a function. This is not a function. But we're gonna go ahead and do our test of symmetry for the practice, okay? So here we go. Change the sign on X. Now, some of you guys are really quick at stuff. Think about putting in a negative X and squaring it. Are you gonna end up with the same equation?
Yes.
Yes. So you don't necessarily have to write all of this down if you can tell. Now, of course, the more work you show, the better chance you have of getting partial credit, so think about that too. But I don't want you to hate these problems. They don't take that long. So this is a yes. Yes. All right, how about if we change the sign on Y?
Yes.
That would also be a yes, wouldn't it? Everybody agree? Well, even because you had this up there. This is also yes, though. This one has nothing to do with even and odd. Remember, even is this, odd is this. These two other ones are just there. All right, how about the identity? What if we switched y and x? Yeah? So that's a yes also. And how about if we change the sign on both of them? Is that the same? So this guy is crazy. He has all of the symmetries. But again, that makes sense because it's a circle centered at the origin. Think about that. Is that symmetric to the y-axis, x-axis, this line right here, that's your identity line, and the origin? Absolutely, circles are symmetric to everything. Right? They're symmetric. Okay. So a question you're asking yourself is, oh my gosh, it's even and odd? Yeah, this thing is even and odd, both, because it has both symmetries. But remember, it's not a function. Okay, it's not a function. All right, let's do one more, which looks like it might be a challenge. G. All right, we'll do G. We are not going to be bored. We are hugely enthusiastic about our tests of symmetry. All right, change the sign on X. Same thing? No, we are not even. That's a no. We are not even. Okay, how about if we change the sign on Y? Is that the same thing? Nope. Everybody following along okay? You're gonna have to do this by yourself sometime. Everybody good? Okay. Switch X and Y. Now be careful with this one. It looks different. But when in doubt, get y by itself. So I'm gonna multiply the y over to here and divide by x. What happened? It is the same. That's a yes. So remember, you're allowed to just kind of eyeball it. But if you're at all concerned, confused, or wonder, get y by itself and see if it matches. And then how about if I change the sign on both? That will say negative y equals 1 over x, because these will cancel. And then if I multiply by negative 1, it will say y equals negative 1 over x. Yeah, so that's a yes. So that means that this function is odd. And I'll just show you, you don't need to know this right now. Eventually in this unit you will. But right now I'm going to tell you this is what that picture looks like. This right here looks like this. Here's the origin. Does that have symmetry about the origin? It sure does, right? Aiden, honey, you okay? You need to stand up? Go ahead, stand up. Do a push-up, do a burpee, do whatever it takes to get that blood flow. Huh? You just came from lunch. Take the emergency pass, hurry up, get your butt back here. Your mom and I have communication. All right, so that takes care of that. Number 4, even odd. What's even mean? You have symmetry about the y-axis. What does odd mean? Symmetry about the origin. I'm in my notes now. This is page 12, number 4. We're going to remember odd is origin, and I don't know how you're going to remember even is y-axis. All right, now we have number 5. This is an extremely important thing, so I really need, the drinking fountain is like 4 steps away from this. I need everybody paying attention to doing this. All right, so now we're going to talk about domains. Now, the important thing to remember here, 2 rules that you must cement into your brain. Now, word problems have their own issues, but straight, what you doing, man? There's one's right there, you weren't there. Word problems have their own things going on, but all these regular equations, there are 2 things that you have to remember. Someplace write these down, because if you remember these, you will be able to answer all of these questions. Okay? Here we go. The first rule is the denominator can never equal 0. So if your problem has a fraction in it, whatever the denominators are, they cannot be 0. Okay? The second rule is, if your problem has a radical, whatever is under the radical has to be greater than or equal to 0. Now, both of those things make perfectly good sense. What happens if you put a negative under there? We're odd. We don't want odds. We are in real number land. So those are the 2 things that you consider. So I'm looking at problem A. Does problem A have a denominator? No. Does problem A have a radical? No. So therefore, the domain is everything. All real numbers, negative infinity to infinity. These are the things that limit your domain. Fractions cause problems, radicals cause problems. No fraction, no radical, no problem. Okay? So let's look at letter B. What's going on with B? It has a denominator. And what do we know about denominators? They cannot be 0, right? Which means that x cannot be 3. So what's my answer? Everything except 3. So that would be negative infinity to 3. And then 3 to infinity. Now I know that's kind of a lot to write, but that's how you gotta write it. On the number line, it would look like this, right? Uh-oh, look at C. What's going on in C? We have 2 fractions. So x can't be 0, and x minus 3 can't be 0, which means x can't be 0 and x can't be 3. Now, I always like to think about a number line because this would be my answer, right? I have those 2 open dots. So negative infinity to 0, 0 to 3, and 3 to infinity. Yes, that's a pain in the butt, but that's how we do it. Okay? Now what about D? Things are starting to get interesting. What about D?
No, there's a radical and
Denominator, we have a radical and a denominator. So the denominator rule says that x plus 1 cannot be 0, and x squared plus 1 cannot be 0. That's what the denominator rule says. All right, let's take care of that thing first. This says that x can't be -1. Okay, now wait. This says x squared can't be -1. What's gonna happen when I try to solve that? It's an I, and I's are not part of our conversation, so we're not worried about that one. If it's not real, we're not talking about it in terms of doing it. So far, this is where I am. All right. Now tell me about the radical part of that problem. 4 minus x, is that 4 minus x? Yeah. Has to be greater than or equal to 0. Because your radical rule says that whatever's underneath has to be bigger than or equal to. All right, so what does that say?
It works.
Negative x is greater than or equal to -4. X is less than or equal to 4. Kellen, you're nodding. Is that what you got? All right, this is tricky. I need to look at it on the number line. Here's 4. Here's less than or equal to 4. But I can't be -1. So I'm less than 4. But I can't be -1. So that would be part of the answer, but so would all of that. So my answer to D is negative infinity to -1, union with -1 to 4, and 4 has a bracket. would you work on E, F, and G? Work on E, F, and G with your partner. I will work on them also. Remember your rules. You are only concerned with denominators and radicals. Hi. He talks all the time.
Oh, that's a good thing.
Let's go. We're working on those last three with our partners. Gotta figure out what the domain is. All right, figuring it out. Caitlin, you got the hand up to the answer?
Yeah. -3, yeah. So what do you
It's called. I just had
you score negative and you get because that's what you're going to get behind. You don't even worry about it. Should just be negative.
All right, what did you come up with, guys? Let's see what you've come up with. Did anybody, let's have an answer and then we'll check it and see if you're right.
Negative 2.
Two?
Yep. Bracket the negative 3. And then 2.
All right, anybody agree with Elijah?
Yep.
All right, let's take a look at it and see. Our rule says whatever's under the radical has to be greater than or equal to 0. So Elijah's thinking x has to be bigger than -2. So that's where he's starting. Okay? Then our other rule says the denominator cannot be 0, so x cannot be 2. So he has an open dot at 2, right? So what changes? Everything from -3 to 2 and everything from 2 to infinity. He's right. Did you have his answer? Yep, good job. All right, how about this one? Anybody come up with an answer to this one? Okay, Tyler, is there a radical to worry about? No, good. The only thing you have to worry about is the denominator. So x squared minus 4 cannot be 0, which means you can solve this a couple ways. I don't know how you did it. Did you bring the 4 over and then square root? That's perfectly okay as long as you remember what? Plus or minus, very good. You might also have factored this, x plus 2, x minus 2. Difference of squares, if that's easier for you. Okay, so what's that answer look like? You need an answer. So, -infinity to, watch it. Here's my number line. I have open dots at -2 and 2. So I am going from -infinity to -2. And then from from -2 to 2, and then from 2 to infinity. And I know that's a pain in the butt to write all that, but that's how we do it. That's right, gotta do it. Gotta do it. Okay, last one of these. Tyler? Yeah, yeah. Okay, so listen, Tyler's question is, what about the 3x cubed? What do I worry about when the question is domain? A denominator and a radical. If it's not a denominator and it's not a radical, then in a question of domain, I don't even impact it, okay? Now, it will impact the range, it will impact the picture, but in terms of domain, denominator and radical, okay? Do I have a denominator? Yes. So my denominator cannot be 0? Did anybody try to solve that? You're gonna get an I. And what did we say about I's? No part of this conversation. So what did you put as the answer to this? Oh, no, the opposite of no solution. All real. Because, remember, we're looking for issues. We're looking for things that cause trouble. And in this problem, the only thing that would cause trouble is an I. And we don't even talk about I's. So therefore, there's nothing that causes trouble. And the domain is -50. All right, we got 2 minutes. We're going to do number 6. And we can do this. Number 6. Function or not function? Who remembers? Yes, because it passes the vertical line test. Do you remember the vertical line test? You don't remember it? Okay, vertical line test is when we take a picture and we start passing vertical lines through it, and as long as we only hit one time, we're a function. Number F. Okay. So B, function?
No.
No. C is a little tricky. There's no picture, it's an equation. Anybody know what a y squared looks like? Not y squared. If it's squared, it's a parabola. But be careful. X squared is a parabola that opens up or down. So y squared is a parabola that opens sideways. Is that a function? No. How about D? Last one, and then I'll shut up. Last one. D. Yes, because it is linear. And every line is going to be a function except the vertical line, right? All right, there we go. At some point, we're going to have a